Good day, students. Welcome to math.serve.com, and this clip we're going to be going over how to find and verify inverses. Okay, let's take a look at the instructions. We are to find the inverse of the given function and verify our results algebraically. Okay, we're going to verify the accuracy of our results algebraically by composition. Now, there's a graphical verification for verifying the inverse of functions, but that is not what we are going to be using in this presentation. All right, so let's say we have the function f of x equals -3 divided by x plus 1 plus 2. So the task here is to find the inverse of this function and then verify that our result is in fact correct. Let's start by taking a look at part 1 of the whole process. In part 1, we are to find the inverse of f. Okay? So what we're going to start with is the original function, which is f of x equals -3 divided by x plus 1 plus 2. So when we're finding the inverse, what we are simply going to do is switch and solve. We're going to switch the output function with the inverse, with the input, and then the input function will switch with the inverse of the output function. Okay, so let's go ahead and carry out the switch process. Take away the f of x, replace with x, and that is equal to -3 divided by, take out x and replace with the inverse of f. Okay, plus 1, and this entire quotient plus 2. Now the goal is to get f inverse of x isolated. This can be accomplished by 4 steps. We are going to first of all get rid of this 2, and then we'll reciprocate this rational expression here to have the inverse function in the numerator. We'll get rid of -3 and then get rid of +1. This plus 1 here that is being added to f inverse of x. Let's go ahead and do it. So we'll subtract 2 from both sides. I'm going to go ahead and switch my equation around. So I will have -3 divided by f inverse of x plus 1 equals x minus 2. Now we have the function, the inverse function that we want to solve for in the denominator. So we want to try to get it in the numerator. Okay, so to accomplish this, we'll express both sides of our equation as a fraction. And what we're going to do next is reciprocate both sides of our equation. So we just reciprocate it. We can do this because we have 2 fractions, algebraic fractions, on both sides of the equation. Okay, so upon reciprocation, we are going to get f inverse of x plus 1 divided by -3 equals 1 over x minus 2. Now the next step is to get rid of negative 3. This can be accomplished by multiplying both sides of the equation by negative 3. Okay, so let's go ahead and do that. Multiply both sides by negative 3. And negative 3 is divided out to 1 on the left side. So we will be left with the inverse of f of x plus 1 equals negative 3 divided by x minus 2. Now the final step is to simply subtract 1 from both sides of our equation, and the inverse function will be isolated. Okay, so we subtract 1 from both sides of the equation, and that yields the inverse function f inverse of x equals negative 3 over x minus 2 minus 1. Okay, so this is our first result, the inverse of f. So the question is this result correct? We are going to verify the accuracy of this result by composition. This will be a two-part composition process. We will compose f with the inverse and then proceed to compose the inverse with f. Let's start by composing f with the inverse in part 2. Part 2, we are going to be answering the question, is f composed with the inverse of f equal to x? If the answer is yes, then that's excellent. We will proceed to part 3, because that's basically what inverse functions do. When you compose them with each other, you end up where you started from, namely x. So let's go ahead and carry out this verification. We'll start out by writing out the formula, the expanded form of this condensed composition notation. F of f inverse of x is equal to f of f inverse of x. So the question is, what does this mean? This means we're to take the inverse function that we found, negative 3 divided by x minus 2 minus 1, and substitute it into all the x's in f of x. To help us stay organized, we'll start by writing down the outer function. The outer function is f of x. F of x equals negative 3 divided by x plus 1 plus 2. Now we'll proceed to get the outer function prepped. We will clear out all the x's and replace it with parentheses. Negative 3 divided by, now this part of the equation, this x, will take a look at the inverse function, take a look at its size, and that will help us determine the dimension or the width of our parentheses. Okay, so let's make it sufficiently large to compensate for its size, plus 1 in the denominator, plus 2 for the entire rational expression. The name of the input function is f inverse of x. The value is what we got down here. Let's take a look at it. Negative 3 over x minus 2 minus 1. So what we'll do now is proceed to simplify this expression we have on the right. Imagine as though there is a 1 out here. If we distribute that 1 into this quantity, we will end up with negative 3 over negative 3 divided by x minus 2 minus 1 plus 1. This entire rational expression plus 2. Now what do you see happening in the denominator here? These are inverses of each other. They add up to 0. Minus 1 plus 1 is 0. So we are left with negative 3 divided by negative 3 over x minus 2 plus 2. Now we have two negatives dividing each other, so we can divide them out. Minus over minus is plus. So how can we divide a number by a fractional algebraic expression? We're going to do this by using the drop, change, flip procedure. Okay? That is how to divide fractions, complex fractions, where the numerator and or the denominator are fractions. So what we'll do first to set up the process is to express both numerator and denominator as fractions. So the 3 in the numerator can be written as 3 over 1 divided by 3 over x minus 2. This entire expression plus 2. Now we are going to proceed to drop, change, flip. So what is drop, change, flip? You simply drop the numerator exactly as it is, 3 over 1. Change your division into times, and you reciprocate the denominator, x minus 2 over 3. This whole idea is based on the fact that dividing is the same thing as multiplying by the reciprocal. Plus 2. Now what happens on the left side? These two 3's divide out. We have 1 here and 1 here. And that gives us x minus 2 plus 2. X minus 2 plus 2 minus 2 plus 2 is 0. We're left with x, and that is exactly what we are looking for. So put a check mark. Part 2 works out. Now what we're going to do is proceed to the final part, part 3. In part 3, we're going to carry out the reverse composition and see if we end up with the same result that we did in part 2. So what is part 3? Part 3 is the reverse composition. We're going to be asking ourselves the question, is the inverse this time composed with the function, is it equal to x? If it is, then we can conclude that our inverse is accurate by composition. Okay, let's go ahead and do it. So we will start by writing out the expanded form of this composition formula, f inverse composed with f of x is the same thing as the inverse of f of x. So what are we going to do here? We're going to take the function and plug it into all the x's in the inverse function. To help us stay organized, we'll start by writing down what the inverse function is. F inverse of x that we found earlier was negative 3 divided by x minus 2 minus 1. We will now proceed to get the function prepped. So we'll clear out all the x's and replace it with parentheses. So we have f inverse composed with something divided by, equals negative 3 over, take a look at the size of f of x, make your parentheses sufficiently large to compensate for its size, minus 2 minus 1. Okay? Now we'll proceed to plug in our input function. The name of the function is f of x, and the value is negative 3 divided by x plus 1 plus 2. So if you're taking a look at what we did previously in part 2, there's a great similarity in the process. So you can basically use your work from part 2 to guide the process in part 3. Okay, so imagine that you have a 1 here. You can distribute the 1 to the denominator. That gives us negative 3 divided by negative 3 over x plus 1 plus 2 minus 2 minus 1. Now what happens in the denominator in this quotient expression on the left? Plus 2 minus 2 add up to 0. So we're left with negative 3 divided by negative 3 divided by x plus 1. We now have a complex fraction. And this entire complex fraction minus 1. So if we think about what we did in part 2, how did we resolve a complex fraction situation? How did we convert it into a simple fraction? We drop, change, flip, right? So let's go ahead and express the numerator as a fraction, negative 3 over 1, divided by the denominator is already an algebraic fraction, minus 1. So what we'll do now is drop, change, flip. Drop the numerator exactly as it is. Change the division into times. And then reciprocate the denominator and multiply it by the numerator. Now, why does this work? Well, it is because, as indicated earlier, dividing is the same thing as multiplying by the reciprocal. And we have minus 1. Okay, now the negative 3's divide out, and we're left with x plus 1 minus 1. Now what happens here? Minus 1 plus 1 divide out. They combine to give you 0. Okay, so we're left with x, and that is exactly what we're looking for. So by composition, we've been able to show that our inverse function is correct. So we'll put a little box of accomplishment to show that we have completed our proof. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of functions, composition, and other procedures, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Do not forget to subscribe to our channel. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.